Let us try to understand the concept of limits using the epsilon-delta definition. For this, let's consider a random function, say fx is equal to x square, and a point 2, 4 on its graph, which we denote by p, l here. We know that the limit of this function, x square as x approaches 2, is 4. But what does this statement really mean? To understand this, let's choose a small positive number epsilon. Suppose we take epsilon is equal to 1. This means that we draw a horizontal band extending 1 unit above and 1 unit below the point 4 on the y-axis. This shaded region is what we will be calling as an epsilon band. Our goal is to find out a small interval of radius, let's say delta, around x is equal to 2 on the x-axis, such that whenever x stays inside this interval, the corresponding value of fx remains well within the epsilon band. In other words, we want mod of fx minus 4 is less than 1, which means x square is between 3 and 5, which means x is between root 3 and root 5. Notice that these two numbers are roughly 0.2 units away from the point 2 on the x-axis. Hence, choosing delta is equal to 0.2 will work. So we draw a delta band around x is equal to 2, where delta is 0.2. Now we can clearly see that whenever x stays within this delta band, that is whenever mod of x minus 2 is less than 0.2, the corresponding function value, which is f of x, automatically stays within the epsilon band. That is mod of fx minus 4 will always be less than 1, which means that the distance between fx and the point 4 on the y-axis will always be less than 1. So to conclude, we can say that whenever x stays sufficiently close to 2, the value of fx also stays sufficiently close to 4. And this is exactly the idea behind the epsilon-delta definition of limits, which means that for every epsilon positive, there is a delta positive such that whenever mod of x minus p is less than delta, that is distance between x and p is less than delta, distance between fx and l is less than epsilon.